right, number 2. We got 4 parts again, so this time they use Q of x, and again they'll change that letter, so don't fret about that. We have x minus 3 quantity squared plus 7. And we want to find the vertex. So remember, we're going to do opposite of this sign, same sign here. So our vertex for part 1 is going to be 3, positive 7, positive 3, 7. And then we want to know how many x-intercepts. So let's find the x-intercepts again. Let's say part B, x-intercept. We've got to know that the y value is 0. So I'm going to say 0 equals x minus 3 squared plus 7. We're going to subtract 7, and that will give us negative 7 equals x minus 3 quantity squared. And then we're going to take the square root of both sides. So this is not real. This is an imaginary, because we cannot take the square root of a negative number. Imaginary square root of 7. And then we would have x minus 3. And then from here I'm going to stop, because what this means is that our parabola is floating up in space and will not cross. So we're probably going to have a scenario like this. Our vertex is at 3, 7, so 1, 2, 3, and then up 7, and then it's opening up. So this graph is not going to cross the x-axis. And so we're not going to get any x-intercepts, so we're going to say none. Okay, so now we want to find 2 points on the graph other than the vertex and the intercepts. So since we don't have intercepts, we just cannot use 3. So we can use any other numbers we want. And again, for something simple, I guess I'll just use the next point to the left of the vertex. So that's something that you can do that's really easy. So you start with your vertex, and you can just move 1 point to the left or to the right. And so that's what I'll probably do from here on out, because as you'll see, it's going to give you 2 points. This thing has a property that is symmetric, okay? So it means it's, once you find that vertex, it splits this thing right in the middle. And so if I were to go to some point over here, say 2, and I get my y value, it's going to be the same value when I go 1. So this order pair is 3, 7. So as I move 1 in either direction from the x, the y value is going to change by the same amount, meaning whatever your y value is. So if I move 1 to the left, I get the same y value as if I move 1 to the right. So whatever I get for 2, I will get that same y value for 4. And if I were to move 2 and I got a positive 1, and I move 2 to the right, whatever I got for 5, it would be the same y value. So let's just work that out and see, and then we'll go from there. So we're going to use x to be 2 and 4. All right, so we're going to do q of 2, and that's going to equal 2 minus 3 squared plus 7. So 2 minus 3 is 1, negative 1. Negative 1 squared is a positive 1. So we get 1 plus 7, and so we get q of 2 is 8, and that ordered pair is just 2, 8. Plug in the 2, we got 8. So I'm going to plug in 4 now, and so what I was trying to explain is that when you plug in the 4, you're going to get the same y value. So we should get the order pair 4, 8, but let's verify it. So we get, open parentheses, 4 minus 3 squared plus 7. So 4 minus 3 is a positive 1. When you square that, you still get a positive 1 plus 7, and then you end up getting q of 4 equals 8, and so you get the ordered pair 4, 8 because of that symmetric property. So that's easier. You can just find 1 point, plug in one number and you get the other one for free. So 2, 8, and 4, 8. 4, 8. Not sure what I hit, but it didn't like that. And then step 4, we're going to graph the parabola. So we're going to just drag this vertex over to 3, 7. 1, 2, 3, up 7. And then we'll go and take this point. So 2, 8. It looks like it's already in the right spot. Go over 1, up 1, 2, 8. That looks good. So those are already in the right spots that we need. And 4, 8.